Hi, here we are in another session of WindTalks, coordinated by the Basque Energy Cluster that are taking place in this wonderful Bilbao Wind Europe conference. Um, Today, we are going to talk a bit more about the digitalization and remote monitoring, and more specifically, this first chat is going to be about the digital twin of the electrical components of the drivetrain. For that matter, I have the luck of being here with two experts from two Basque companies. First of all, here is Jorge Acedo, who is Director of Wind Digitalization in Ingeteam, a leading provider of converters all over the world. And I'm also here with Eugenio Perea, Head of Digital Energy in Tecnalia, again a reference technology center in the Basque Country, and also a top contributor in R&D in Europe. We want to talk about digital twins in drivetrain mainly. First question is starting from the basics. What is a digital twin and which are the functionalities of a digital twin?
Who may start?
Okay, I can give just a brief introduction,
Okay.
more market related than technical.
Okay.
As you know, now there is a strong pressure to reduce cost. And when talking about critical components such as power converters, this means to optimize both the initial design cost, the CapEx, and the operational lifetime, the OpEx. Digital twin technology is a useful tool to help optimize the OpEx during the lifetime. This is from a broad perspective. More technically speaking, I'm sure that Eugenio, you can give us some clues.
Yes, I will give the technological view. We are a technological center. There has been lots of literature about the digital twins. Some of them dealing with the 3D points of certain assets. What do we think is a digital twin? Digital twin is a virtualization of a certain equipment, critical equipment in a, for example, wind farm. Virtualization means it's an evolution from the simulations, static simulations, into dynamic simulations, models that are embedded in a certain ICT platform that take data from real operation, SCADA data or condition monitoring data, and try to predict what will happen in the taking into account wind speed or whatever in a near future, and if operational normal situations, failure modes, etc., etc.
And which are the technical challenges for developing a digital twin?
Okay, we have a lot of experience doing predictive maintenance for mechanical systems. For example, Ingeteam is now maintaining more than 12 gigawatts of renewable power. These systems, most of them are mechanical, like gearboxes, and we are experts in vibration, monitoring, oil, and this is well established. However, when talking about power converters and about electrical systems in general, we find that the physical models that are involved, the type of failure modes are much different than the experience that we have from mechanical systems. Therefore, we are working during some years in understanding how the design models that we already have, how they can be enhanced to work as a digital twin, to allow to predict the future, so as to add value to our clients, to reduce the OpEx.
Okay, in this sense, which are your currently technical undertakings in developing the digital twin?
Okay, coming back to the previous question and
Sure.
coming to the next one also, the difficulty is that the energy domain companies, they know a lot about their products. They know a lot about the design. They now are in a career for having new knowledge in digitalization. So the models must be calibrated with real data, and we cannot have lots of errors. So we must introduce new technologies like the artificial intelligence, the machine learning.
Okay. And are there also non-technical challenges?
Well, yes, there is a lack of data.
Okay.
There is a lack of real wind farms with data, at least for the technological center, there is a lack also of failure data, because this is something core in the business of the companies. So, and what he was pointing out also, the knowledge of the critical failures and how many times and with what probability may occur.
I think that the technical challenges sometimes are also related to non-technical. So, coming back to technical challenges, when we analyze the parts of our power converters, some of the subcomponents are very complex, such as the semiconductors. So we have built models for example, for junction temperature estimation. But what happens is that these new models might require design changes, and then we go to the non-technical challenges, that these design changes involve and can involve sometimes an increase of cost.
Okay.
So we have to balance the pressure between the short term, the initial capex, and the opex. And this is a non-technical challenge, because we have to take business considerations.
The total cost of the
yes,
company.
And also the needs of our clients. Now the market is auction driven.
Yeah.
So auctions are critical. So it's not a good time to increase the capex. So everything is joined together, and for this reason it's very important to work very closely with the OEMs, with our clients, the wind turbine manufacturers, to address these challenges.
Okay. And are you pursuing other initiatives connected to digitalization or to digital twins?
Okay, now we are involved in a very important Basque funded project. It's called Virtual, which is dealing with digital twins in certain different sectors, Industry 4.0 and also the wind energy. There we are researching about cables, power transformers, generators and power converters. And each of the components, they have their own specific targets, objectives, challenges. In the first two, we are investigating things about condition health monitoring. The last two about the digitalization, digital twin of this equipment.
Okay. And
I would like to go back to this question also, because other initiatives that I think are relevant is that we have found out that it is very important to have all the data along the life cycle, and this is not easy. What we are currently doing, we have our own software tools called Ingeboards, in which you can track the history of all the O&M activity that has taken place, because this is the starting point to get access to the data, as you previously mentioned. So one of these challenges is being addressed through this platform created by Ingeteam called Ingeboards.
Okay. And you've talked a lot about the business case of digital twins, but will digital twins also allow to provide new added value services?
Go ahead.
Definitely. We have to take into account also that it's very important to have in mind that our components, electrical generators and power converters, are part of the wind turbine. Therefore, these components, we know that they have to be digital, both physical and digital, and they have to add new value to our clients. And the particular form of the business model, it will depend on the market, on each situation, and on each client. For us, it's very important to be very closely aligned with the OEMs, and so we will adapt the new business models to the business models of our clients.
Okay. I will talk more in a theoretical aspect, because, well, we are not a company itself. What happens in the value chain is that the traditional established value chain is being changed through the digitalization, and then equipment manufacturers, like could be Ingeteam, also could be positioned in another place, trying to give more added value services to their clients, trying to give operation and maintenance services from the software as a service business model, for example.
Okay.
So I think it could be a revolution in this value chain. Yeah.
Okay. Thank you very much. I think that covers most of the time we had for this wind talk, but it's been very interesting. I think it's quite clear that digital twins are here to stay. So thank you very much to both.
Okay, thank
Thank
you
you.
for your opportunity, given the opportunity.